All right, hello everyone. We are going to start in a minute. We are just giving one more minute for everyone to join, and then we'll get started. Okay, so I think we are going to get started. So hi everyone, I am Sophie Bonnard. I work in the Climate and Clean Air Coalition Secretariat as the Methane flagship coordinator. And I'm joined today by my colleagues Nathan Borgford-Parnell and Jingyi Yi, with whom we coordinated this report, which is bringing us together today. So first and foremost, thank you very much to all of you for joining us today for this first session of the online launch of the Global Methane Status Report. We are very happy to present you with this report, which is the result of several months of work from over 90 experts around the world. So together, they've worked to provide you with a clear picture of progress on methane abatement since the Global Methane Pledge was launched, as well as with an assessment of the remaining gap and to showcase a range of solutions for increased and accelerated action on methane. So the report, maybe you've heard, was successfully launched last week on 17 November at COP30, where it supported the important momentum on methane that happened there. So it has captured global media and political attention, with headlines appearing in several important newspapers, and with methane emerging as one of COP30's most reported topics. So it was important to us to organize these online launches to give you an opportunity to interact with the lead authors of the report. So many of them are with us today, and will take you through the key findings and conclusions of the report. And so we only have 1 hour and a packed agenda. So we are going to get started. And if you can move to the next slide, Jingyi, please. So we are going to start with key highlights of the report that will be presented by Nathan Borgford-Parnell with the CCAC Secretariat Science Affairs Coordinator. Then we will move into chapter 2 of the report, which is about global progress analysis on methane emission. And this will be presented by Lina Hoagland-Isaacson from the International Institute for Applied System Analysis. Then we'll get into the key messages on the global outlook of methane policy and measures, going through the different sectors. So we'll have Chris Mallet on national planning, Irina Isakova from carbon limits on energy, Aditi Ramola from ISWA on waste, and Marshall Bernou from FAO on agriculture. Then Stephen Hamburg from the Environmental Defense Fund will present us with the key findings of the chapter on observed emissions and the role of empirical data. And then we will conclude with the final chapter of the report on financing methane abatement, which was led by Lauren Sidner from MIT, who will be represented by Jingyi Yi, our colleague at the CCAC Secretariat today. After the presentations, we have planned for a 15-20 minute Q&A. Your mics will be enabled for this part of the launch, but please feel free to use the Q&A function to ask your questions during the presentation at any time. So with this, Thank you again for being with us today, and I'm going to turn to Methane Borgford-Parnell, the CCAC Secretariat Science Affairs Coordinator, to present you with the highlights of the report. Thank you.
Thank you very much, Sophie, and thank you all for joining us for this virtual launch of the Global Methane Status Report, the GMSR, as we call it. This comes at a really critical time. This report began as an interim status update report, the midterm status review for the Global Methane Pledge. The Global Methane Pledge, I'm sure all of you know, countries that joined it committed to a collective goal of reducing global methane emissions to at least 30% below 2020 levels by the end of this decade. It's critical. It turned out to be much more critical than that, and much more timely and important, because we are now more than ever, the world is more cognizant of the fact that we are facing a 1.5 degree overshoot world, with great consequences for human society and the environment, if we continue on this path. And this is the year that every country party to the Paris Agreement submitted their NDC 3.0, which is the mitigation commitment of each country that covers the remaining period of the Global Methane Pledge, and in fact extends those commitments out to 2035. For those of you who don't know, who aren't experts and well versed in methane, just as a quick refresher, methane is the second most important greenhouse gas behind CO2. It's approximately responsible for about a third of the warming that we are experiencing today. And because it is short-lived in the atmosphere, it's the fastest and most cost-effective way that we have to slow climate change today, known collectively as a climate emergency brake. Just every fraction of a degree that we either avoid in terms of warming or we produce in terms of cooling matters. It matters for the climate, it matters for human society, it matters for the environment, it matters for air quality. And so every single ton of methane that we can reduce or avoid in terms of emissions will produce significant near-term benefits. My role here today is to provide a couple of high-level conclusions from the report, and then hand it over to the CLAs for each of the individual chapters to dive much more deeply into the conclusions and main messages from the report. And I want to leave you with three key messages from the report. And the first is that we have to recognize that methane emissions are continuing to rise. And that's happening for a number of reasons. But the outlook is improving, and improving dramatically, and it is improving in part because of the collective ambition and action of the global community laid out in the Global Methane Pledge. When we first signed to the Global Methane Pledge in 2021, we forecasted emissions trajectories and based those climate mitigation commitments based on those forecasts. We have now, based on the action that's been taken since 2021, been able to revise those forecasts down. We are now expecting methane emissions, anthropogenic methane emissions, to grow less quickly than what was expected in 2021. And that is because of, in large part, the actions of GMP partners really focusing on methane. That's message one. Message two, political commitments to mitigate methane emissions have surged since 2021. Two-thirds of the parties to the Paris Agreement have included methane in their national plans. This represents a 38% increase over 2020 levels of commitments. And within the NDC commitments that are represented in the NDC 3.0s, if countries stick to those commitments and fully implement the measures and the mitigation policies that they've outlined in the NDC 3.0s, we expect that we will reverse the trend of anthropogenic methane emissions increasing, and we could actually see an up to 8% decrease in methane emissions within this decade. That is obviously not the 30% reduction that we are committed to in the Global Methane Pledge. However, if we do achieve this 8% reduction, it would represent the largest and most sustained reduction in anthropogenic methane emissions in recorded human history. And that is worthy of praise. It's not enough. Much more needs to be done. Much more can be done. But that is a significant shift in terms of bending the curve and providing enormous benefits for the climate and public health. That having been said, as I said, that's an 8% reduction is obviously not consistent with the target of the Global Methane Pledge. However, in this assessment, we have identified that there are existing measures that exist and have been put into place in many places in this world, which, if fully implemented globally in all three main emitting sectors for methane, we could reduce global anthropogenic methane emissions to below 30%, below 2020 levels by 2030. The Global Methane Pledge is still within reach, but the levels of ambition, the level of action would have to be increased dramatically within this decade. And of course, then the world continues to spin after 2030. More action is needed beyond 2030, out to the midpoint of the century and beyond. Another benefit of these measures, not only do they exist and have been applied all over the world, but over 80% of that mitigation potential is available at low cost. Certainly, when you account for the public health and the agricultural and the climate benefits on top of the actual cost of the measures, the value proposition of mitigating methane is a slam dunk. There are almost no measures that you cannot justify in terms of the value add that is provided by reducing tropospheric ozone, and the public health impacts related to reductions in tropospheric ozone, as well as avoided warming and improvements in agricultural production. Now is the time to take action. This is the midpoint for the Global Methane Pledge. As I said, the point of this report was to take stock of where we stand and see where more ambition is needed, where more action can be taken. Obviously, a lot of action has occurred, but we know that more is needed, and we have identified the pathways to achieve those increases in ambition and the technologies and the benefits of doing so. And now I would like to close and hand over to the leads of the various chapters to go into a little bit more detail about those conclusions and the pathways that will lead us to really pulling this methane climate handbrake and achieving the climate benefits that I know we are all most interested in. So thank you very much for your time, and I will hand it now over to either Sophie or Lena for the next portion.
Yes, Lena, please, the floor is yours.
Thank you, Nathan and Sophie. So I will talk about the global progress analysis that we did for methane emissions. So for this analysis, I think maybe you can go to the next slide, please. So for this progress analysis of the status of global methane emissions, we start from a baseline scenario that reflects the expected development in future emissions with no further uptake of legislation to control emissions than currently implemented. So since 2020, methane emissions from human activities have risen by a few percent. Agriculture accounts for 42% of emissions, dominated by livestock, followed by rice cultivation. The energy sector accounts for 38%, in particular fugitive emissions during oil, gas, and coal extraction, and waste and wastewater for 20%. The G20 plus group of countries, which here refers to the 19 largest economies, and in addition, Norway, Switzerland, New Zealand, Iceland, and the rest of the EU member states, account for as much as 65% of global emissions. With current legislation, global emissions are expected to increase by 5% between 2020 and 2030, and by 21% between 2020 and 2050. So as we heard from Nathan, this is a somewhat slower growth than projected in the 2021 Global Methane Assessment at the time of the launch of the Global Methane Pledge, when a 9% increase in emissions was expected between 2020 and 2030. Important reasons for the slower growth are investments into improved waste management in the last 2 decades, having net negative effects in particular on current waste emissions, in particular in high-income regions like Europe and North America, as well as an assumption that production of unconventional gas will peak in 2025 instead of steadily increasing. The latter being an assumption that is currently challenged by the most recent developments in global energy markets. So next, please. But a 5% increase between 2020 and 2030 is still far from the pledge target of a 30% reduction. So what about countries' current plans for methane reductions? So here we scanned through the national determined contributions and methane mitigation roadmaps and action plans as submitted by countries by June this year for measures explicitly or implicitly targeting methane emissions. If all the mentioned measures are fully implemented, the current rise in emissions could reverse and translate to an 8% reduction between 2020 and 2030. So even if it is not enough to meet the pledge target, as we heard also from Nathan, such a reduction would still be the largest drop in methane emissions in recorded history and correspond to a 0.06 degrees avoided warming by 2050. Because methane also acts as a precursor for the formation of ground level ozone, a pollutant that damages health as well as crop yields. The foreseen methane emission reduction would also prevent 60,000 premature deaths and over 6 million tons of crop losses per year to a value of about $100 billion. Next, please. So meeting the pledge target requires further raising ambition. With maximum implementation of existing technology to control methane, emissions could be reduced by as much as 32% between 2020 and 2030, thereby avoiding a 0.2 degrees warming by 2050, with the benefits of avoided effects of ozone formation valued at over $300 billion per year. 72% of the maximum technically feasible reduction potential is found in the G20 plus group of countries. Next, please. So the ambition level needs to ramp up, but the good news is that many measures are cost effective and over 80% of the technical mitigation potential is available at a low cost of less than $1,000 per ton methane or $36 per ton CO2 equivalent. The cost of full implementation of all existing technical measures by 2030 is estimated at $127 billion annually. The energy sector holds 72% of the global technical mitigation potential in 2030, agriculture 18%, and waste and wastewater 10%. So the energy sector is really important in terms of the mitigation by 2030. The waste sector holds also significant mitigation potential, but with effects on emissions primarily expected post-2030, because large amounts of organic waste already deposited into landfills will continue to decay and release methane in the coming years. But it underlines the importance of investing early into improved waste management. Next, please. So the report also lists some more than 40 proven technical measures that we have identified to reduce methane emissions, along also with their mitigation potential and cost in the different scenarios. And this is what we see here. But I would encourage people to look in the report for the details. Next, please. So in the longer time frame, so beyond 2030 and going into 2050, methane mitigation action and ambition must continue and be strengthened. So if full implementation of the existing technical mitigation potential is combined with parallel efforts to both decarbonize the global energy systems and transition to healthier, more plant-based human diets, and reduced generation of food waste, global methane emissions from human activities could be more than halved by 2050. And this would actually be consistent with pathways keeping within 1.5 degrees of global warming. Thank you very much. And I will hand over to the next speaker, who is...
That's Lina.
Yeah.
And yes, we are going to turn to the key findings of chapter 3 now, the global outlook of methane policies and measures. And so we'll start with national planning. And Chris Malley from the Stockholm Environment Institute could not be with us today, but he has recorded a video to present to you the key messages from his section on national planning.
Hi, thank you very much for letting me be part of the launch of the Global Methane Status Report online. It's nice to be here. I was an author on the national planning part of the report, and in contrast to many other sections of the report, which provide sobering reading in terms of how close we are to achieving the Global Methane Pledge 5 years on from its establishment, within this section of the report, we do see some very positive trends on parts of the Global Methane Pledge below the overall target of reducing methane emissions by 30% by 2030. We used as an analytical framework in this section of the report both what the pledge says that countries commit to by participating in the pledge, which is to work together to achieve a 30% reduction in global methane emissions, yes, but also to move to the more advanced methodologies for monitoring methane emissions within their domestic borders and working on domestic actions to reduce methane emissions. So we took that as our starting point as to what we wanted to assess and evaluate within this section. And then we used the framework developed as part of the Climate and Clean Air Coalition's Methane Roadmap Action Programme initiative, which aimed to support countries to take that global pledge and downscale it to identify what contribution an individual country can make. The Methane Roadmap Action Programme has 5 building blocks that constitute a methane roadmap: the ability to assess one's emissions, to have the analytical capability to evaluate policies and measures, to be able to set targets on methane, to understand implementation pathways, and then to be able to look at monitoring. We see positive trends across each of these different building blocks. On the emissions and monitoring part, there has been a huge step change, particularly among developing countries, in the number of countries that are using tier 2 and above IPCC methodologies to quantify methane emissions. For example, in developing countries, in non-Annex 1 countries to the UNFCCC, there's been a 69% increase in the number of countries using tier 2 plus methods to quantify emissions from livestock, and a 50% increase to quantify emissions, methane emissions from waste. When we look at targets, the floor for methane targets that we look at when we look at NDCs is whether a country includes methane within the scope of its overall greenhouse gas reduction target. And on a country by country level, we see that most countries do that, but there has been very significant progress on that in recently, with China now moving to set its NDC targets covering all greenhouse gases, including methane. Methane was not included previously. So this is sort of the minimum that we can say that a country has a target to reduce methane, when reducing methane will contribute to achieving your overall NDC target, providing a motivation to take action on methane. There's far fewer countries that take the extra step of establishing what the methane component of that overall target is. We do see some leaders there with 31 countries establishing some sort of methane specific target within their NDCs, whether an overall methane target or a percentage reduction in a particular sector, for example. When we then look at the building block on pathways, if we analyze the NDCs, there's been a huge increase in the number of countries identifying actions to reduce methane in agriculture, in waste, and in fossil fuel production since the Global Methane Pledge was established. About 65% of countries, and this number is already out of date, it's higher than that as new NDCs have come out during COP30, include methane-specific actions within their NDCs, which is more than a 50% increase compared to before the Global Methane Pledge was established. So we see a lot of positive trajectories when we dig below the uncomfortable truth that methane emissions are still increasing. We know that people are monitoring methane more accurately and precisely using more detailed and appropriate methodologies. We see that people are committing to more actions, setting methane targets. What we need now is for that to translate into implementation on the ground. One thing we've seen in the progress that we track in the national planning activities is that much of this has been led through actions in developing countries. We need all countries now to begin to work together to ensure the finances there, to ensure that national planning, national commitments on methane are translated to specific projects, into specific projects that can actually reduce methane emissions. So that's the type of thing that we'll be looking out for as the Global Methane Status Report gets updated over the next few years. Thank you very much.
Thank you. And we are now going to turn to the section on energy, and it's going to be presented by Irina Isakova from Carbon Limits. And she as well could not, unfortunately, be with us this morning. So she has sent as well a video.
Hi, everyone. Pleasure to be here. My name is Irina Isakova, and together with Jonathan Banks, we were lead authors for the section related to fossil fuel sector. So I'm happy to present you some of the key messages from the work. And I would really like to thank everyone who contributed to this chapter. First and foremost, it's the second largest source of anthropogenic methane emissions globally. But more importantly, it is the sector that offers the greatest potential for rapid and cost-effective methane abatement. If we implement the maximum technically feasible reduction potential as per Gaines model, the analysis that was done for this report, emissions in 2030 can be reduced by almost 80% compared to the current legislation scenario. So these are drastic cuts that can be achieved with the technologies that exist today. Some of the measures using these technologies are also at low cost or even negative abatement cost, depending on the technologies and the region where they implemented. And while we need to continue to decarbonize the energy system, which we know will lead to methane emission reduction by itself, it is not enough to just focus on that. Again, based on the analysis in this report, this will not reduce methane emissions fast enough for us to achieve neither global methane pledge nor the overall targets of the Paris Agreement. So we need to continue working on decarbonization of the energy system, but also on targeted additional immediate methane mitigation in order to stay on track. Over the last few years, we have seen an important growth in understanding of emissions and in mitigation action taken by both governments and industry. Momentum has spread to every producing region, South America, Asia, Europe, Africa. There are governments that have adopted and drafted and implemented dedicated plans for abatement. However, this is not sufficient, and under current legislation scenario, emissions are expected to rise by 8% in 2050 compared to 2020. So expanding the adoption of policies to other countries and really enforcing them where they have already been drafted remains key. In addition to policy, there have also been a few voluntary schemes like OGMP 2.0 and OGDC that have significantly grown over the last years and now cover around 40% of the global oil and gas supply. These initiatives can help where methane rules are still forming and enforcement capacity is limited. They can improve data quality and they can provide the peer-to-peer support that can really accelerate knowledge and technology transfer. In the coal sector, on the other hand, the experience has not been as good, or the progress has not been as good as in the oil and gas sector over the last years. There is urgent need for innovative approaches to overcome the existing barriers, with particular attention to no-regret policies, such as pre-mining degasification and abandoned mine methane capture, as well as mine closure planning. And finally, despite the important progress, there are existing barriers that prevent from methane mitigation happening quicker in the fossil fuel sector. Some of them are related to limited technical capacity globally, uneven data transparency, limited access to finance and technologies in some regions, as well as structural barriers, especially in the case of national oil and gas companies. Enhancing MRV frameworks, as well as improving or performing increased leak detection and repair campaigns across the globe is really important. LDAR is not only mitigation action in its own, it can also provide important information about operations and the main sources of emissions. And that, as part of the MRV, is very important in order to understand emissions and really know where to target mitigation actions. Facilitating access to finance and capacity building remains very, very critical. And also for the coal sector, setting clear mitigation targets and ensuring proper sealing techniques during mine and well closure are important actions to be considered. Overall, the fossil fuel sector offers unparalleled potential for rapid methane mitigation, and it has to be maximized if we are to meet our targets.
So yes, we are now going to turn to the waste sector after the energy one, which, as Irina underlined, bears the critical opportunities for methane over the remaining years of these decades. And waste, as outlined by Lina earlier, also represents important opportunity, including beyond 2030. And so with this, I'm turning to you, Aditi. So we are welcoming Aditi Ramola, a lead author of the waste section of the report. The floor is yours, Aditi.
Thank you so much, Sophie, and hello, everybody. It's been an honor to be part of this report, along with Carlos Silva Filho and several other colleagues from the waste sector who have actually joined us today on the call, who contributed to the chapter. So many thanks go out to them. So in my short intervention, I'm going to be focusing on what the GMSR 2025 tells us about the waste sector. So in this report, the waste sector includes both solid waste and wastewater. So it includes basically municipal solid waste, industrial solid waste, as well as domestic and industrial water waste systems. So these are places where organic matter decompose under anaerobic conditions and release methane. As Lina mentioned in the beginning of the presentation, waste already contributes approximately 20% of global anthropogenic methane emissions. So what really happens in this sector matters in the long run, whether if you want to achieve the global methane pledge or not. So on this first slide, you're basically seeing a global outlook of methane policies and measures in the sector, in the waste sector. And first, the trend is without any additional action. So if we simply continue with the current practices, methane emissions from the sector are projected to increase by about 13% by 2030 and by 56% by 2050 when you compare to 2020 levels. And this growth in emissions is basically mainly driven by population and economic growth, and by also by, in a contradiction, by expanded waste and wastewater collection and treatment. So this happens even though this expansion is absolutely necessary. It's in fact the first step that we tell municipalities and cities around the world to do. It improves public health. It moves us away from open dumping, open burning, and brings very important environmental benefits. But unless we introduce targeted methane mitigation measures in parallel, those same improvements can actually push methane emissions, at least in the near term. They can push them up. Second, what happens if we fully deploy methane targeted measures? The modeling that was carried out by our colleagues at IASA, Lena and team, the report is showing that full deployment of these technical measures in the sector could reduce annual emissions by 13 million tons of methane per year by 2030 compared to the current CLE or current legislation emission scenario. And this is because, as Lena mentioned, dump sites and landfills continue to emit methane for many years after the waste is deposited. So any kind of benefits that we want to see will take some time to show. And so, those measures are projected to deliver around 21 million tons of methane reduction per year by 2040, as those emissions from legacy waste start to fall. So the message is very clear. As we heard already, we must act early. So if we wait for another decade or so to act, we're not going to be able to retroactively fix the methane emissions that have already, been baked into our landfills today and so on. And the third message, of course, is economics. We cannot not talk about financing. And these opportunities, the mitigation opportunities within the sector are very cost effective, which you heard from other speakers as well. The report that was launched estimates that these measures can deliver around savings of around $9 billion per year by 2030. This is because the methane that we capture now can be used as an energy source that can offset fossil fuel use and so on. So this is basically low cost savings. So if we do nothing extra, if we keep going on the business as usual path, waste sector methane emissions are going to rise sharply. But if we deploy all the measures that are available or the technologies that we already know, we can bend that curve down. So that's the key messages that came out of the report. If you move to the next slide, Jingy, please. So on this slide, we are going to be moving from what is possible to what it takes in practice. So let's talk about the good news first. Of course, you heard the emissions are going to rise, but there is good news. The report is highlighting that several countries around the world are already showing significant methane mitigation in the waste sector is achievable because they are deploying technologies for collection, also for treatment. And these are basically cost effective and they come often with net savings, benefits on health, environment, and so on. And so we see this, as Lena mentioned, in the last 20 years, we've seen good investments in waste technologies in high-income countries, and with that, we've seen emissions decrease. So that could include landfill gas capture, separate collection of organics, composting, anaerobic digestion, and so on and so forth. So any kind of circular solutions for organic waste. But after the good news comes the news that we need to focus on, which is basically there are lots of barriers that still remain, especially in low and middle income countries around the world. And we are quite explicit about what's holding us back. So this could be anywhere from weak regulatory frameworks and enforcement. Many countries have good laws in place, but enforcement is weak. Also, we noticed that there isn't enough infrastructure capacity and technical capacity. For example, people are calling landfills, which are not even properly engineered. They don't have proper controls. They're actually dump sites being operated as dump sites, but being called landfills. There are many organic treatment facilities around the world which don't have actually good trained operators, and so on and so forth. We also see that financial systems are fragile. So if you don't take into account the OPEX of the system, it's bound to collapse or stop working after a few years. And we also see that there are underdeveloped markets or not enough demand for valorized outputs, for including compost or biogas or BSFL products, which is black soldier fly larvae products, and so on. And finally, we see that there is fragmented governance across many countries and multiple agencies within different levels of government. So all those need to be worked on before we can actually start seeing improvements in the sector. And it goes without saying, we need to also bring a lot of awareness and behavior change within our communities and so on. So all these factors basically constrain us moving into integrated waste management systems, and so thereby preventing our ability to, get good organic fractions, valorize them, and get them at scale. So I'll end with, what do we really need? What kind of change do we want to see on the ground? And the report makes it very clear that to see this effective mitigation of methane emissions from our sector, which is waste, solid waste and wastewater, we need, of course, systemic change, which is going to be needed to be supported by a comprehensive policy framework. So that means bringing about regulatory measures, whether it's for, maybe you have standards for engineered landfills, maybe you make it mandatory for people to separate organics at source, and progressive diversion of organic waste from disposal and so on. We need to be looking at economic instruments that make low emissions options the rational choice. Basically, people shouldn't have a choice but to do the right thing, including getting waste fees in place, tariffs, and so on and so forth. And of course, it goes without saying, we need to have good investment in infrastructure and capacity as well, from community level interventions to citywide interventions as well. So to end, I just want to say that if we treat our sector, which is including the wastewater sector, as a strategic climate development priority, and if we align policy, we bring local implementation, get the financing right, we can turn what is today, because you've heard the news, it's a growing source of methane emissions, especially because of, as I said, growing populations and GDP rising. If we get catalytic investment into these good solutions, then we can get better health, better, cleaner cities, green jobs, and long-term climate stability as well. So that was my last slide. I want to pass it back to Sophie. Thank you.
Thank you so much, Aditi. And we are going to turn now to the third main emitting sector, which is agriculture. And so the lead author for this chapter is Martial Bernoux from FAO. Unfortunately, he just informed us that he had an emergency this morning. So I'm going to myself quickly take you through really the key findings of the section on agriculture. So it's not, it's quite an important part of the report, because agriculture is the largest source of global anthropogenic methane emissions today. And without additional mitigation, emissions from the sector are expected to rise by 8% by 2030, mainly due to increases in livestock populations in Africa and in Latin America. Yet, the sector has the technical potential to reduce emissions by up to 8% below 2020 levels by 2030. And there are low-cost mitigation options that exist, including improved rice cultivation, bans on agricultural waste burning, especially in Africa and Southeast Asia. On the livestock subsector, there are also a number of options which are slightly costlier, but offer significant potential, especially in America and in Western Europe. And the report is going through those different options. Another important mitigation option, which is outlined in the report, is the building of climate-resilient livestock systems in smallholder and pastoralist settings that can deliver multiple benefits, from improving productivity and reducing emissions. So what this section of the report assesses is that mitigation ambition in the agriculture sector has increased over the past year, but policy coverage remains limited and very uneven. In terms of key recommendation that the lead author is leaving us with, is that today we really mean, and it's kind of echoing what Aditi was saying for the waste sector, Today, we really need to turn to holistic, equity-based policies to avoid any unintended consequences, such as shifting emissions to unregulated source or increasing food insecurity and rural poverty. So we are seeing that today financial, institutional, and technical barriers persist. But if we were to only redirect a small share of all of the agricultural subsidies that exist today, and if we were to improve MRV systems, we could unlock important progress and really link mitigation to development co-benefits. So that's really the main conclusions of this section on agriculture, and Marshall sent his regrets not having been able to be with us today. So now, after the looking at each of the different main methane emitting sectors, as you've seen, data has been and MRV have been underlined as important barriers, as well as key area for rapid progress to unlock mitigation across the three emitting sectors. And so now I'm going to turn to Stephen Emborg from EDF to tell us about the key finding of this chapter on observed emission and the role of empirical data for methane abatement. So Stephen, the floor is yours. Thank you.
Thank you very much. And it's a real pleasure to have been part of this report. I have to stress, I want to start with a point that's been made by our speakers, which is mitigation options are readily available. So the good news here is that we do know how to address emissions from methane. And the other part of that is to see those emissions and to really accelerate that progress. We really need measurement-based data. It's absolutely essential. Why? Because it gives you the clarity of understanding of what's happening that generalized calculated data does not. And to do that, we need high quality data, which are absolutely feasible at this point in time. It allows us both to accelerate those mitigations and assess those reductions. And towards that end, one of the things that we have in the methane space is the ability to bring all of that data together through the International Methane Emissions Observatory, which is part of UNEP as well. And IMEO really brings us the tools that we don't have elsewhere to assemble the data and integrate that so that we get the clear picture that we need to really be able to drive the possibilities of mitigation and the deliverance of those reductions forward. As we make these reductions, tracking those emissions is absolutely essential. And we have the methods to do that. And I have to stress that because often we talk about it, well, it would be good if we could. We can do it. We have demonstrated that, particularly through the fossil fuel sector, where we've been working assiduously, both in the public sector and the private sector, to bring these data together and to develop the methodologies. That allows us to track changes, which is, as I said, quite clear. And as I mentioned, the fossil fuel sector gives us a confidence that we're able to understand these changes and be able to bring those understandings forward. But these same data also tell us that we have underestimated these emissions, and that without clear, high-quality data, we won't understand the problem effectively and assign and undertake mitigation in the right places. So we know how to do it, we know how to track it, and we know that those make a big difference in being effective. So basically, we have to bring our toolkit to the problems that we've been talking about. When we do that, we get a high-quality result, we get a clear understanding of what's happening, and we can prioritize action moving forward. And towards that end, we want to make sure that we bring good testing and validation of these data so that we're making sure that everybody is using the best available knowledge. Bottom line, we have a good news story here. we have the ability to measure methane emissions at a much greater rate than we did recently. These data prove very effective in driving mitigation. And when we bring these data together through IMEO, it's possible to see and understand the problem far better, and in so doing, make much more greater progress. Thank you.
Okay, and so now we're going to turn to the financing of methane abatement, which has also been underlined as one of the key barrier and factor of success. And I'm going to turn to you, Jingy, to cover for Lawrence Sidner the lead author of this chapter. Thank you.
Hello everyone, good to see you here today. My name is Jin Yi and I'm one of the authors of this chapter. So here today I represent of the lead authors, Lawrence Sidner, and also the other authors. So first of all, I would like to thank for all of the contributors behind the report and this chapter as well. So this chapter primarily relies on the GANS model unit abatement cost data to really estimate what the investment is needed, and also use the CPI climate policy initiatives analysis of the tracked methane financed to contextualize these kind of estimates. So first of all, the CPI analysis shows that the tracked methane finance has actually tramped up in the recent years, reaching to $30.7 billion on average in 2021 and 2022, but it still falls short of the estimated 2030 investment needed to achieve the GMP target. According to the GANS model, the cost in 2030 to implement MTFR, which is maximum technical feasible reduction scenarios, it's around $127 billion per year, as also stated by our previous presenters. So as you can see here, the table also shows a more detailed breakdown between the different costs in the three sectors and their annual savings as well. So the energy sector measures marked up the majority of this cost, nearly around $98 billion in the cost annualized by 2030. While it is significant, but the fossil fuel companies, they have the primary responsibilities for investing in methane mitigations. And in fact, this kind of estimated cost represents a very small fraction of the sector annual net coming in these recent years. And for agriculture sector, the measures have the second largest cost at around $38 billion per year by 2030. It also represented a small fraction of the estimated public subsidies to the sector, and also stated previously, if we redirect even a very small portion of like insufficient or harmful public subsidies to this sector, it could actually help close the investment gap. Well, in waste sector, if we account for the potential gas savings, the estimated annual cost to implement the measures are actually net negative. But it is also important to recognize that in this sector, there is some high uncertainty in aggregated investment needed. So in fact, investment in this sector will have to direct or shift towards or scale up to some critical measures such as landfill gas captures and advanced wastewater treatment facilities, etc. And another important point of this chapter is to recognize that reaching the level of the investment needed, it requires various of resources, ranging from supporting to technical assistance, to capacity building, and research and development, to project preparation, to conception of finance, and also to commercial capital as well. But it is also needed to stress that access into capital, it isn't always the only or the primary barrier to agreed actions on methane. For example, inadequate policy incentives, data limitations, and institutional capacity or variable projects, these kind of factors often needed to be addressed in parallel, which means that a wide variety of actors, they all needed to step up, for government to philanthropy, to development finance institutions, to private sectors like corporations, financial institutions and investments, etc. So it is also important to recognize in this chapter is that methane abatement advanced other core development priorities. As we also heard in the waste sector, it include and agriculture sector, it include increase of productivity and resilience, and also the improvement of health outcomes. And this kind of core development priorities or benefits are aligned well with the missions of development banks. So for example, and also for the private sectors, what they could do is probably they could consider investing in methane mitigation in their own operations as supply chains, and consider methane in their procurement and also carbon credit purchase strategies. And last but not the least, this chapter walked through a lot of real-life examples of different progress and positive steps. It really demonstrates what it might look like for these different kind of actors to really step up, to coordinate their efforts, and to catalyze the investment. So in conclusion, so this chapter really shows that a substantial outstanding investment gap exists, but the scale of resources needed to achieve the GMP target is still achievable. Thank you very much, and I hand it over to Sophie.
Thank you so much, Jingi. And this is an opportunity to note that, supported by the findings of this report, almost 300 million in new funding for methane abatement was announced at COP30 by government and philanthropy. So still not enough, but a step toward what's needed to meet our objectives. So we've seen, I think, overall that in essence, this report is telling us that we have built a strong foundation since the launch of the Global Methane Pledge, but that now is really the time where we must accelerate and scale up to strengthen policies, to enhance measurements and reporting, and to significantly increase financing for implementation. So we are a bit late on our timing, yet I would like to allow one or two questions if there are any from the floor. So right now you should be able to raise your hand if you'd like to ask a question. So the floor is open before we conclude. Okay, and if there are no questions, I've seen in the chat that someone asked for the presentation from this morning. We'll make it available to everyone for sure. And so I think we are getting we are arriving at our 1 hour. So I would like to thank you all for participating to this launch. Thank all of our lead authors for being here with us today and presenting you with the key findings of their work. And I hope that this report will act as a real motivation for the year that's going to ahead of us and toward COP31, so that we really make methane one of our key priorities going forward. Thank you so much, everyone. And we remain, of course, available for any question you may have following this launch. Thank you.